In the world of heavy machinery, there is a silent killer at work. It's microscopic, it's relentless, and you know what? It's responsible for most of the expensive, production-stopping failures out there. Today, we're pulling back the curtain on hydraulic contamination.
So just how big of a deal is this? Get this, a staggering 75%. That's right, 3/4 of all hydraulic system failures come from this one single cause, contamination. It's not about bad designs, it's not operator error, it's about tiny, unwanted intruders in the system's lifeblood.
And the fallout from that 75%, whoa, it is huge. We're talking about a massive financial drain. And it's not just the cost of swapping out a broken pump. No, it's the lost production from downtime, which for some industries can mean tens of thousands of dollars per hour. You've got the constant replacement of fluids and parts, the crazy high cost of getting rid of that waste oil, and this endless, exhausting cycle of more and more maintenance. It is a very expensive problem hiding in plain sight.
Okay, so if we're going to fight this problem, we first have to know who we're up against. Turns out, there are three main suspects, three hidden enemies that can bring a multi-ton machine grinding to a halt.
All right, our first and honestly most common enemy we'll call the grinder. This is just particulate contamination, tiny solid bits of metal, sand, rubber, you name it, that sneak into the hydraulic fluid. They are literally the grit in the gears, grinding away at your machinery from the inside out.
And the grinder has two main ways of attacking. On one hand, you've got silt. These are particles smaller than 5 micrometers. Think of this as death by 1,000 cuts. It's slow, gradual wear and tear over a long period of time. But then, you've got the chips, particles bigger than 5 micrometers. These guys are the assassins. A single chip can cause an immediate, catastrophic failure, jamming a valve or scoring a cylinder in the blink of an eye.
And this picture shows perfectly why it's so nasty. See, a hard particle gets wedged between two moving surfaces with incredibly tight clearances. This initial hit doesn't just damage the parts, it actually breaks off more particles. And guess what? Those new particles go on to cause even more damage, creating this vicious, ever-worsening chain reaction of wear that spreads through the whole system.
Now let's move on to culprit number 2, the corroder. You probably know it as water. Water is everywhere, right? And its ability to cause absolute chaos inside a hydraulic system is so dangerously underestimated. It does a lot more than just cause a little rust.
So here's the key thing to understand. There's a big difference between dissolved water and what's called free water. Hydraulic oil can actually hold a tiny bit of dissolved water, no problem. But once it gets saturated, any extra water becomes free water. That's what you're seeing when the oil gets that milky, cloudy look. And that is when water does the most damage, corroding metal, breaking down the oil's additives, and just destroying the fluid's ability to lubricate.
And if you want to see just how bad it is, look at this chart. This shows what water does to the life of a typical bearing. With clean oil, you're at 100% of expected life. Great, but add just a tiny bit of water, we're talking 0.1%, and you have just slashed that bearing's life down to only 40%. It's an absolutely devastating effect from what seems like a harmless amount of contamination.
Our third and final enemy is the sponger, also known as air contamination. Now, unlike particles or water, air sabotages the system in a totally different way, by changing the fundamental properties of the hydraulic fluid itself. You see, hydraulic systems work because fluid isn't compressible, but air absolutely is. So when air gets trapped in the fluid, the whole system gets, well, spongy. The pump starts wasting energy just compressing air bubbles instead of moving fluid to do work. This means less power, foaming in the tank, higher temperatures, and it speeds up the breakdown of the oil itself.
So we've met our three enemies, but here's the real challenge. The most damaging ones are completely invisible to the naked eye. So how in the world do we find them? Well, this is where we shift from the crime to the investigation.
And that really is the million-dollar question, isn't it? If the particles causing all this long-term damage are too small for you to see, how can you possibly get a handle on them?
The answer starts with just getting your head around the scale we're talking about. A grain of table salt is about 100 micrometers. A human hair? Maybe 70. The absolute limit of what you can see is around 40 micrometers. But look at this. A red blood cell is only 5 micrometers. Those super destructive silt particles we talked about, they're in that exact same range. They are totally, completely invisible, and yet they're everywhere.
So, to see these invisible particles, the industry uses a standardized forensic tool. It's called the ISO 4406 cleanliness code.
You can think of it like a fingerprint that tells us exactly what's lurking in the fluid.
Now, this code might look a little complex, but the idea behind it is actually super simple. It's just 3 numbers that tell you how dirty your oil is. The first number counts the really small particles, the second counts the medium ones, and the third counts the big ones. The higher the numbers, the dirtier the oil. It's a simple, really powerful way to measure an invisible threat.
All right, so we know the enemies and we know how to find them. Let's switch gears from investigation to prevention. It's time to build a strong defense. Let's talk tactics, and these are brilliantly simple, but they're so effective. First, and I can't stress this enough, filter all new fluid. Oil straight from the drum is almost never clean enough for a modern system. Second, get high-quality breathers on your reservoirs. The old-style caps are basically a wide-open door for dirt. Third, keep up with your seals and wipers. They're your frontline soldiers against grit. And finally, always flush a new system before you start it up to get rid of all the junk left over from manufacturing.
Now, when it comes to filtration, there are 2 basic ways to think about it. You've got surface filtration, which works like a simple screen, just catching particles on its outer layer. It's very precise. Then there's depth filtration, which is more like a maze, trapping particles all through its complex web. It can hold a lot more dirt. The right one really just depends on what you need it for.
So as we start to wrap this up, it's really important to remember the big picture. We've talked about particles and water and air and filters, but what's this really all about?
This quote just says it all, doesn't it? You don't filter oil just to have clean oil. You filter oil to protect your investment. The real goal here isn't just a clean system. It's a more reliable, more productive, and less expensive operation. This is a direct tool for boosting your bottom line.
So the crucial thing to take away is this: that 75% failure rate, that's not just something that has to happen. It's a choice. The silent killer is inside your machines right now. So the only question left is, what are you doing to stop it?